Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. An anhydride forms when two carboxylic acid groups that are in close enough proximity, typically on adjacent carbons, condense with loss of water to form a cyclic anhydride, 5-membered ring. A dianhydride requires two such pairs of adjacent CH groups, each pair forming one anhydride ring. Step 1. Analyze structure. A. The 4 CH groups are at positions 1, 2, 3, 4 of the benzene ring, all on one side. The pair at C1 and C2 are adjacent can form one anhydride ring. The pair at C3 and C4 are adjacent can form a second anhydride ring. Therefore, structure A 1, 2, 3, 4 benzene tetracarboxylic acid can form a dianhydride with two 5-membered anhydride rings. Step 2. Analyze structure. B. The 4 CH groups are at positions 1, 2, 4, 5 of the benzene ring. The pair at C1 and C2 are adjacent can form one anhydride ring. The pair at C4 and C5 are adjacent can form a second anhydride ring. Therefore, structure B 1, 2, 4, 5 benzene tetracarboxylic acid, pyromellitic acid, can also form a dianhydride, pyromellitic dianhydride, PMDA, which is a well-known industrial compound. Step 3. Why not option? C. Both structures are capable of forming dianhydrates, so neither is incorrect. Step 4. Conclusion. Both A and B poses two pairs of adjacent CH groups on the benzene ring, enabling each to form two cyclic anhydride rings, i.e., a dianhydride. Therefore, the correct answer is D. Therefore, the correct answer is option D.